Hello, my name is Jeremy, and I'm here to talk to you about the small angle approximation. The small angle approximation
uses the basic trigonometric functions and approximates them. These approximated functions become more accurate as the angle approaches zero. This can be used in many areas, such as mechanics, electromagnetics, optics, and cartography. It is also used in astronomy, and is still widely used throughout today. The idea behind it is that as the angle approaches 0 radians, the opposite approaches a value of 0. Therefore, as the angle approaches 0 radians, we can say that the hypotenuse approximately equals the adjacent. Therefore, sine theta approximately equals tan theta, which approximately equals theta.
In astronomy, the small angle approximation can be used to calculate the diameter of planets or distance between two objects.
The closer the angle is to 0 degrees, the more accurate the approximation becomes. It works in astronomy due to the fact that most of the angles that are used there are incredibly small. By understanding geometry and the nature of circles, it is possible to determine the distance to an object or the physical diameter of objects in space. In astronomy, the sizes of celestial bodies are commonly measured by their angular diameter relative to Earth, as opposed to their absolute size. Angular diameter is the angle that an eye, or camera, needs to rotate in order to look from one side of a circle to the other side.
Stellar parallax is another way that the small angle approximation is used to calculate the distance of stars. Parallax is the observed change in the position of an object, which is the result of a change in the position of the observer.
A good analogy is walking down a path with trees on one side and mountains in the background behind them. As you walk down the path, the trees would appear to be moving past at the speed you're walking, whereas the mountains would appear to be moving at a much slower rate, even though in reality they are both moving at exactly the same rate. Specifically in the case of astronomy, it refers to the apparent change in position of a nearby star as seen from Earth. The parallax of an object, in this case most commonly a star or planet, can be used to approximate its distance from Earth. From the surface of the Earth, parallax angles of less than 0.01 are difficult to measure because of the effect created by our atmosphere. This limits our telescopes based on Earth to measuring stars only about 100 parsecs away. Orbital telescopes are affected far less by our atmosphere, and thus can achieve accuracy to about 1,000 parsecs away. This is still not enough for most stars in our own galaxy, however, as they are generally over 1,000 parsecs away, and the Milky Way itself is about 30,000 parsecs across.
Thank you for watching. I hope you enjoyed our video and learned something new today. Until next time, adios!